It's Dr. Milam, and we're on the 8th day of our e-learning journey. Oh Lord, it is a journey. So Dr. Milam's going to give you your next lesson. I did want to tell you that I am going to send out a link for Math Jeopardy. I'm a little late getting this video done and a little late getting the invitation to you, but I think we're going to try for this afternoon. I was going to do 12 noon. But I think that we're going to try a little bit later as long as, as long as the link is available. All right, so I'm going to go ahead and get started. The lesson is going to look a little different today because I'm going to actually teach from the teacher version of it, or the answer key. And so I decided to do that today since I was a little late in getting a video to you. Hopefully the video won't be as long because I'm not taking the time to try to write it. Okay, so let's see. So yesterday I did the lesson on dividing a whole number by a unit fraction. This lesson is dividing a unit fraction by a whole number, so everything is a little bit different. Let's take a moment and do the application problem. So it says that a race begins with 2.5 miles through town, continues through the park for 2 1/3 miles, and finishes at the track after the last 1/6 mile. A volunteer stationed at every quarter mile and at the finish line to pass out cups of water and cheers on the runners. How many volunteers are needed? And I have to tell you that I had a group of my friends last fall do the Chicago Marathon, and I actually was that volunteer that was stationed at one of the quarter miles. And I was actually toward the end of the 26.2 mile run. So it's kind of, these are like real life problems. So it says a volunteer is stationed at every quarter mile. How many volunteers are needed? Well, if they are stationed at every quarter mile, I actually need to know how long the race is so that I can then take the total amount and divide that into quarters. Okay, so what they did here was they actually then added each of these pieces up. So 2.5 plus 2 1/3 plus 1/6. What did they do? They found a common denominator of 6 out of 2, 3, and 6. You could multiply those three together. I don't know why you would, but you could do that. And then they just added those that had the same denominator. That was intentional. So 3 plus 2 plus 1 is 6. So it's, and then we have the two wholes. Remember, this only works for addition. We cannot do this for subtraction. And so 2 plus 2 is 4, and then this is plus 6, 6, which is 5. So this is actually a 5-mile race. And so what they did was they then took the 5 miles and then they divided it into quarters. So let me get my, let's see. Let me get my tools up here so I can at least show you. So this is a mile. This is a mile. This is a mile, and a mile. So they took that 1 mile and then they divided that into fourths. Okay. So if we look at the number, if we look at the fourths, how many fourths are in 1 mile? There are 1, 2, 3, 4. 1, 2, 3, 4. There are 4. So this is 4. And then there are how many of them? 1, 2, 3, 4, 5. So 5 times 4 is 20. So we're not doing 5 times 4. We're doing 5 divided into fourths, and that amount is 20. So 20 volunteers are needed. Okay, you can replay that. And I'm going to go right into the problem set. Okay. All right, so it says draw a model or tape diagram to solve it. Let's use a thought bubble to show your thinking. Write your quotient in the blank. Use the example to help you. All right, so Pedro, here's an example, a student example. And so the example that's here says 1/2 divided by 3. And so if you're looking for like why do these problems exist? Like why would I have something like that? Just think about like if you had a half a pan of brownies. Let's just say that that's what this example is. I've got a half a pan of brownies, and there are three people that want to eat some of those brownies. You want to divide it equally. So you actually would take, first of all, you have to represent a half. So this right here is like saying that I've got half a pan of brownies. This is my pan right here. Okay, so this is my pan. Here's half a pan. And I want to take that half and divide it by three people. So what I need to do then is take that half and divide it by three. So I've got three equal parts. Well, whatever I'm doing to this side of my whole, I have to do to the other side of the whole too. So now I've taken this half and divided it into thirds. I've got to take this and divide it into thirds. And so how many thirds do I have? 1, 2, 3, 4, 5, 6. Okay? And so there are definitely 6 thirds here. And then how much does each person get? Well, they would just get this piece. So that's 1 out of 6 equal parts. And so that's why a half divided by 3 is 1/6. Okay? The math of it we know that we learned before, that you've learned in the past, is 1/2 times, and then I've got to flip this. So how can you write 3 as a fraction? That's 3 over 1, and if you flip it, then you get what? You get 1 over 3, which now we know how to do this is 1 times 1, which is 1, 2 times 3, which is 6. Okay, so that's the math of it. And again, I know that that comes from what you learned previously, but this lesson is making sure that you really understand what is being done. Let's do it again. So the next problem that we have is 1/3 divided by 4. So this is again like me saying I've got a third of a pan of brownies. So this is my pan. Somebody ate this, and this is all I have left. Okay? All right, so if I want to take a third of a pan of brownies and divide that into 4 equal groups, meaning I want 4 people to get a piece of what I did. As a matter of fact, my daughter-in-law last night made brownies, and I can't wait to have some today. So they took that 1/3 part of the entire pan and divided that into 4 equal parts. 1, 2, 3, 4, right? But I've got to divide this piece of it and this piece just as well, even though it doesn't exist, because I need to know how much is this out of the entire thing. Okay, because because this was already the thirds, so now if I'm dividing it to fourths, it's not just fourth of this, but the entire amount helps you to see it's 1/4 of 1/3. Okay, and so that was 1 out of 12 pieces. There, 1/3 divided by 4. There are 4/12 that we're dividing by 4, which is equal to 1/12 here. Okay, so again, if you do the math of it, 1/3 divided by 4, we've got to keep, change, and then flip this. So how do we do this? Well, 4 is the same thing as 4 over 1. When I flip it, if you notice, I did not change this. 5th graders, don't make up your own math. Don't start flipping the first, okay? Only flip the second is equal to 1/12. And that's why. But this is why it works. This is what you're actually doing. Okay, we're going to keep going. We've got a pan of Rice Krispie treats. Ooh, that sounds really good, right? So I've got a pan of Rice Krispie treats. 3/4 of it is already eaten. There's a fourth that's left. I'm going to only split that between 2 people. So I'm going to break this into a half. And so each person gets this piece. But I've got to do that for all of the pieces so that I can see how many. 1, 2, 3, 4, 5, 6, 7, 8. So they're getting really 1/8 of the pan of brownies. Okay. All right, again, 1/4 divided by 2 is the same thing as 1/4 times 1/2, and that's equal to 1/8. Okay. All right, let's keep going. 1/4 divided by 3. The math of it, you know. 1/4 times 1/3. Keep, change, flip. And so that's 1/12. This is why it works. So I've got a pan of Rice Krispie treats again that I cut into fours. There's 1/4 that's left. I want to give it to 3 people. And so I'm going to cut that into thirds, not 1/3. I didn't say 1/4 divided by 1/3. That's not what I'm doing right now. I'm just saying take the fourth that you have left over, break it into 3 equal parts. How much does each person get? They get this piece, and how much is that of the entire pan? That's really what it's saying. So if this is in thirds, into 3 equal parts, this is 3 equal parts, this is 3 equal parts, this is 3 equal parts. I've got 12 equal parts, and they get 1/12. Okay? All right, so you can stop the video on this piece of it. I think what you see here in the answers is that they just wrote this. They wrote this as equivalent fractions. So you can see that 1/2 is the same thing as 7 14ths. And so that's divided by 7. And so this becomes 7/14 times 1/7. And so what they did was you can instantly divide this. 7 divided by 7 is 1. What's left here? 1 times 1 is 1. And 14 times 1 is 14. Okay? If you don't like it that way, you can do it exactly the way that we did it before. Okay? So 1/2 divided by 7 is the same thing as, hello, is the same thing as 1/2 times 1/7. And you see that that's the same thing. So that is 1/14. Okay? All right, and that's true for all of these. Okay? I'm not going to go through and do them. You already have the answers there. Okay? I want to get into the word problems here. Again, I am giving you the answers just from the teacher book here, and we're going to walk through what they wrote here. Okay, so Tasha eats half her snack and gives the other half to 2 best friends for them to share equally. What portion of the whole snack does each friend get? Draw a picture to support your response. All right, so this is her whole snack. Let's change colors here. This is her whole snack. Okay, so it says that Tasha eats half. So this part here, Tasha ate. And it says the other half, this half right here, I'm going to put that in pink. She's going to give to her 2 best friends. So that means that her 2 best friends gets to share this. So if you notice that I cut this in halves, like I broke it in half. And so what did they get? She took a half, divided that by 2. 1/2 divided by 2. 1/2 is 2/4. Okay? 2/4 divided by 2 is 1/4. And if you notice, Eureka is using the unit language here. Okay? If we break that into halves here, we have to break this in half just so that we can see how much the entire snack represents. And it's in fourths, so that means that this is 1/4. You can see that directly from the picture. Each friend gets 1/4 of the snack that's left. Okay? Of the snack, they got half of the half. Okay? So it's like saying 1/2 of a half. Well, we know that this is multiplication. So 1/2 times 1/2 is 1/4. Okay? All right, we're going to keep going. And we know that division and multiplication is related. Okay, we know that it's related. All right, So Mrs. Appler used a half a gallon of olive oil to make 8 identical batches of salad dressing. So she's going to take this half and divide it by 8. Okay? Whatever's left in the gallon. So here's my gallon. Here's my full gallon. She only has a half a gallon here. And she's got to take that half a gallon and divide that by 8. So that's where this picture comes from. She drew 8 lines here for half gallon, for this half gallon. But you've also got to break this into parts because you need to see how much of the piece that you're going to give away is of the entire batch. That's just how division works. Okay? So if I broke this into 8 equal parts and I broke this into 8 equal parts, how many of these do I have? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there are 16 individual pieces. They got one little portion of it for that salad dressing. And so they really got 1/6 of the gallon of olive oil in each batch. So you might be saying, well, how come it's not 1/8? Well, I didn't start off with a whole. I only started off with this. So it is 1/8 of 1/2. Oh boy, look at that. We know that this is multiplication. So that's 1/8, look at that, times a half, which is still 1/16. Does that make sense? I think that the beauty of mathematics we just saw, it's really a teaching moment here, okay? So it's still 1/16, however you like interpret it. So if we're doing 1/8 of 1/2, right, that's still 1/16. All right, let's answer B. It says, how many cups of olive oil did she use in each batch of salad dressing? How many cups? How many cups? So if this is 1/16 of a gallon, we have to know the relationship between cups and gallons. So let's start with what we know. 1 gallon is 16 cups. It just happens to work out. So that means that 1/16 of a gallon, meaning if it's 16 cups and I only, how many portions do I have here? 16. Then 1/6 of a gallon is just 1 cup. Okay, you can use the same picture if you want to. Here's your gallon, and it's 16 cups. Well, what's 1 out of the 16? It's 1 cup. I don't know if that is going to confuse you. I can do it here on the side if that's going to confuse you. Again, you can divide this into 16. Here's my 1 gallon. So that means my 1 gallon is 16 cups. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and here's 16. So this is 1 gallon right here. And there are 16 cups. Well, I want 1/16 of a gallon. I only just want 1. Well, how much is that? How many cups is that? Well, there's 16 cups here. So there's only 1 cup. Okay? All right, again, you can play that again a little bit if you're confused. It says Mariano delivers newspapers. He always puts 3/4 of his weekly earnings in his savings account. Let's back up. So he delivers newspapers for a living, or for a side job, or his main job, or his first job. All right. He puts away 3/4 of his weekly earnings in a savings account. Okay. So that means that he would have to take his money and divide it into 4 equal parts. That's what that means. And then he takes 3 of those piles and he puts it in a savings account. So for instance, if he got, let's say that he got 30, I'll make it easy, $36. So if he got $36, okay, $36, how much of that does he put in a savings account? Well, 36 divided by 4 is what? 9. And then, so that means each part has 9 in it, in each pile. He wants 3 of those piles. So that means that he's putting $27 away. Okay, I just wanted to talk about that first. Okay, it says then divides the rest equally into 3 piggy banks for spending at the snack shop, the arcade, and the Subway. Okay, then he divides the rest. So let's just take our example here. So $27 is what he put away in savings. What does he have left? He has 9. It says then he divides the rest equally. So in our case here, he took 9 and divided by 3. And so he would have $3 for the snack shop, $3 for the arcade, and $3 for the Subway. A lot of times in these situations, though, they don't give you what the savings, what's in the savings account. So you have to say that since you don't know, that's your whole. It's just 1. So that's what you're going to see here, and I'm just going to highlight it here. Here's the whole. Okay, here is the whole, and then here's the fourths. Let's do that in another color so you can see it. Oh, let's see. Undo it. Okay. I think because I had it. So here's 1, 2, 3, 4. So 1, 2, 3, 4. There's the fourths. Okay. Then 3 of them. Remember I said that 3 of them, I'm going to use a different color so that you can see it. I'm going to highlight it in yellow. That way you can still see the lines. So here's 1, 2, 3. So 3/4 went into savings. And then he's going to take the rest and give 1/3 to snacks, give 1/3 to arcade, give 1/3 to Subway. Okay, but if I'm breaking this into the 3 parts, remember I've got to break this into 3s, this into 3s, this into 3s. So how many of these divisions do I have, or these parts? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 parts here. Okay, it says what fraction of his earning does he put into each piggy bank? So that piece right there, 3 equal piggy banks. That one little piece is what? It's 1/12. Let's do that in red so you can see it. It's 1/12. Okay? Or you can think of it that this is 1/3 of 1/4. That one little piece is 1/3 of 1/4. Because how much did we start with? 1, 2, 3, 4. So it's 1/3 of 1/4. Is that the same thing? Yes, it is. That's 1/12. Okay, what does the division look like? I took 1/4, this piece right here, and divided that into 3 equal parts. So 1/4 divided by 3 is 3/12 divided by 3, which is 1/12. And so if you see here, again, they're using unit language. All right, so Mariano puts 1/12 of his earnings in each piggy bank. Let's see if that works for our situation. So if we took $36 and we took 1/12 of 36, will we get 3? Because we said that was $3 that he was putting away back earlier in our situation, and it is. It is 36 divided by 12 is 3. Okay. All right, let's keep going. So it says if Mariano adds $2.40 to each of the piggy bank each week, how much does he earn per week delivering papers. So they're working from the back end all the way to the front end. Where we started with how much he made up here for $36 and came down to how much is he actually saving, okay, or how much is he putting into each piggy bank. So let's see what they did here. So they said, well, he put $2.40 into here, here, and here. So remember that was originally broken into 3 equal parts. So how much is this part? Is $7.20. They added these 3 up. Well, if that came from it originally being broken up into 4 piles, then that means that each one of these had to be $7.20. And when you add them all up, you get $28.80. Does that make sense to you? That's kind of like our example up here that there was $3, $3, and $3. That means this was 9. That means this was 9, this was 9, this was 9, and 9 times 4 is 36. Okay, I'll let you replay that one just as well, and that's going to conclude the problem set. Okay, if you have any questions, you know you can always message me. I'm going to set up our Jeopardy now and send you an invitation. All right, see you real soon.